Given f of x equals 3x squared plus 4x plus 2, use the definition of the derivative to find the first derivative of the function and the second derivative of the function. So we'll start with the first derivative. We know that we have to take the limit as h approaches 0 of our function evaluated at x plus h. So that's going to be 3 times x plus h squared plus 4 times x plus h plus 2 minus our original f of x. That's going to be 3x squared plus 4x plus 2 all over h. So we need to go through and expand all of those things in the numerator so that we can see which terms might cancel. All right. I am not going to show every single step here. X plus h squared is x squared plus 2xh plus h squared, and then we have to multiply all of that by 3. So that's going to be 3x squared plus 6xh plus 3h squared. Then we have to distribute that 4, so plus 4x plus 4h, and then plus 2. Then we're going to have to distribute the subtraction into all of the terms in that last polynomial, which is going to make all of them negative. Minus 3x squared minus 4x minus 2. And then we need to see what cancels, and I think we're going to have a fair bit of cancellation. I see a positive 3x squared and a negative 3x squared. I see a positive 4x and a negative 4x. I see a positive 2 and a negative 2. I'm also realizing I forgot to put the h in the denominator, so let's squeeze that back in. And then we can look at what we have left. Each of the remaining terms has an h in it, so we can go ahead and divide that by h. 6xh divided by h is going to be 6x, plus 3h squared divided by h is going to be 3h, plus 4h divided by h is just going to be 4. And if we look at the limit as h approaches 0, that middle term is going to vanish, and we're going to be left with 6x plus 4. So this is our first derivative. We were asked to also find the second derivative, so we need to differentiate this function. So for the second derivative, it's going to be the same limit definition, but instead of inputting our original function, we're going to input the derivative 6x plus 4. So if we evaluate that at x plus h, that's going to be 6 times x plus h plus 4 minus f of x, which is 6x plus 4. Well, minus f prime of x, because we're taking the derivative of the derivative. All right, all over h. Okay, let's see what we get. There's far fewer terms here, which is really nice. When we distribute that 6, that's going to be 6x plus 6h, and then plus 4. When we distribute that subtraction, that's going to be minus 6x minus 4, all over h. We've got some cancellation as per usual. The 6x's and the 4's cancel. And we're left with just 6h over h. But 6h divided by h is just 6. And the limit as h approaches 0 of 6 is just 6. So the second derivative there is going to be 6. All right. Very quickly, I'm just going to make a note. If this was a position function, and x as a variable represented time, the first derivative of a position function is velocity, so this would be our velocity function. And then the derivative of that is acceleration, so this would be our acceleration function. Note that the acceleration here is constant. That means that this function is a quadratic, is what we would get if we had a constant acceleration. If you have a situation where you're driving a car and your acceleration is constant, that means that your position is being given by a second degree polynomial. Just an interesting thing to think about.